Welcome everyone. My name is Jacob Hess, and I'm here to take you from zero to engineer.
Now we're going to break down network IDs and subnet masks. Network IDs and subnet masks. So given a particular network ID, like we have here on the screen, let's look at what the subnet mask is and also the CIDR notation and figure out how our subnet mask and our CIDR notation help us figure out what a network ID really is. Because we can look at this ID, 192.168.1.0, and we can think we know what IP addresses belong to it, but we don't truly know without knowing what the subnet mask is. Alright, so this /24 is called the CIDR notation, or CIDR notation, which means classless interdomain routing. Just remember that this is called the CIDR notation, and normally you'll see it like this. You'll see it like 192.168.1.0/24. And what this means is, this is telling you how many binary digits are turned on in the subnet mask. So let's look at that. 24 binary digits. So our subnet mask is something that's written in addition to our network ID or our IP address, right? So you've heard this before. It's 192.168.1.5 with a subnet mask of 255.255.255.0, right? So that is what we're referring to here. Now, again, the CIDR notation /24 refers to the number of bits in the subnet mask. So here we're looking at the subnet mask, actually. We're looking at it in binary only for now. And we can see that the first 24 bits are all turned on. So that's 8 plus 8 is 16, plus another 8 is 24. So the first 24 bits are all turned on. And if we translate this from decimal to binary, it'll give us 255.255.255.0. And we could use our great awesome chart for doing that, but I figured this one was simple enough, we didn't really need it. Remember, we already talked about if you have all ones in an octet, that always equals 255, so you can remember that, guys. So 255.255.255.0 is actually our subnet mask. And we know this just by looking at the CIDR notation. We know this just by looking at the CIDR. If the CIDR is /24, we know our mask is 255.255.255.0. And if we know our mask is 255.255.255.0, we know our CIDR is /24. So that's how those two are related, guys. They're both masks. Alright, so now we're going to figure out what the mask actually means a little more whenever we're determining what our network ID is. So let's look at an example on that. Here we're changing it up a bit. We're just showing the mask at the top of the screen, and here we have 255.255.248.0. We're going to go ahead and bring up our nice chart here for reference, and we can figure out actually our CIDR notation from the mask directly. Remember we said if we knew the mask was 255.255.255.0, we knew it was a /24 CIDR. Well, in this case we have the mask 255.255.248.0. So let's figure out what our CIDR is there. And how we do that is we're going to look at the third octet here, because we know 255 and 255 is all ones. So these are all ones in the subnet mask here. But 248 is not. We know it, right? We know it's not. And then 0 is all zeros. And the fourth octet is just all zeros. But 248 is the one we got to figure out how many bits there are. Because we know that there's 8 bits here and there's 8 bits here, so that's 16. So in this third octet, we're going to be adding from 16 up until we get to 248 in decimal format, which will give us our CIDR notation. All right, so here's how that works, guys. We have 255.255 and then 128 plus 64, which is 192. Not there yet. 192 plus 32, which is 224. Not there yet. 224 plus 16, which is 240. Not there yet. 240 plus 8 is 248. Hey, there we are. So we know these are our subnetting bits. And everything else is considered to be a host bit. All right, so what does that mean for our CIDR? Well, we knew we had 255.255, and that was 8 plus 8 was 16. So we're at a /16, and then we add /16 plus 17, 18, 19, 20, 21, right? So that's how many bits are in our subnet mask. There's 21 bits in our mask, giving us our CIDR of /21. That's how we get that, guys, from the mask. All right, so now that we know that, let's go ahead and look at an IP address. Here we have an IP address, 192.168.40.55. So what the heck is a network ID? Well, we're given the mask and we're given the /21. And from that, we can figure out what the actual network ID is. It's not always as simple as it may seem. So let's look at an example here. We can start off by knowing that 192 and 168 are going to be a part of the network ID because the mask includes all ones there. And if there's all ones, that means you need to use these numbers, right? In fact, the mask means use all the numbers wherever the mask has a 1. All right? And we'll see that here coming shortly. So if our first 2 octets in our mask have 255 and 255, then we know we need to use the first 2 octets of our IP address in the network ID. So it's going to start with 192.168. Here where it gets a little bit more fuzzy is when we go into the 3rd octet, because that's where the mask is a little bit fuzzy as well. That's where our 21 bits go into. So we're at 16, then they bleed into the 3rd octet until the 21st bit, and then our mask cuts off somewhere in that 3rd octet. So let's look at this a little more closely. That 3rd octet is actually comprised of the following binary digits. It's actually 40, right? And we could easily determine that by saying, oh, 40 is 32 plus 8. So these would be turned on. So it's 001010000. That's how we got that there. Super easy. As long as you have your super cool chart there that I said I wasn't going to give a name, but I ended up giving it multiple names. All right, so here we are. We're looking at the 3rd octet, and the mask bits for 248 are 1111100. And how did we calculate that? We said 128 plus 64 plus 32 plus 16 plus 8 added up to 248. So that's how we knew it was 11111, and the rest of them were zeros. So when we put the mask up against our IP address here, we can see that everything here where we have our mask, all these bits in the IP address need to be used in the network ID, because the subnet mask tells us what our network ID is, or our subnet ID. Subnet mask, subnet ID, network ID, they're all generally the same term. Anyhow, these digits in the mask in our 3rd octet are telling us that 40 is also part of our network ID, because the bits that go along with the extension of the subnet mask here include 40 in them. Now, if our IP address given was 192.168.41.55, then 41 wouldn't actually be part of our IP or part of our network ID. It would still be 40 because our mask said only use these bits here in the mask. All right, we're going to do a few of these, so don't worry. Now, let's go ahead and look at what that actually means. That means that our network ID is 192.168.40.0, and we've written it here in CIDR notation, CIDR notation, by putting the /21 at the end. And we also know that our subnet mask is 255.255.2480. And I've written all these here together because generally that's what you'll do, or generally that's what I do. I write the network ID plus the CIDR notation plus the subnet mask. Sometimes I'll just use the CIDR. It depends on who's looking at my documentation, right? Some people don't know what the CIDR is. But that's how we use our mask to determine what our network ID is. So our network ID is 192.168.40.0, guys, 40.0. And that includes a lot of hosts. These are all host bits here, so we actually have the entire 4th octet, and we also have 3 bits of the 3rd octet are all host bits. So 41.55 is even a host. But I'm not going to get into that. That's where it can start getting a little more confusing. For now, let's just understand how we can take our mask and figure out what the network ID is. Really, dump everything else out of your brain. Just understand this. How do we take our mask and our CIDR and figure out what our network ID is given an IP address? That's what we need to be focusing on right at this moment. So let's look at another example. Here we have the same exact mask, and we have our sweet, super cool chart. Then we have our CIDR notation, and this is all the same as the last exercise, so you know how we figured that out. Now we have a slightly different IP address. It's 192.168.45.55. So what is the network ID? Well, we know again that 192 and 168 will be used in the network ID because we have all 255s in the mask portion of those 2 octets, right? So now we need to look into the 3rd octet here, and we need to break it out into binary. And when we break it out into binary, we see it's 001, 01101. And then when we put that up against the mask in the 3rd octet, we see that these are the only numbers that should match right here. These other bits are actually host bits. They don't have anything to do with the network ID. Only the mask can tell us exactly which bits to use in our network ID. So far they've told us 192.168, and now they've told us also these bits here, meaning that 32 plus 8 equals 40. So again, in this example, our network ID is actually 192.168.40.0. And guys, these are a little bit advanced when you start looking at IP addresses actually. Normally you don't start out looking at IP addresses like this. However, guys, be confident and know that whenever you look at things in binary and you learn it this way, it's so much easier to understand in the long run. That's why we're jumping into some more relatively complicated things right off the bat. So it's a good thing. All right, let's look at another example. Here we have a new mask, and this mask bleeds all the way into the 4th octet, 255.255.255.192. So let's go ahead and think here, and actually let's think without using our chart. Let's just think, what could the CIDR notation be? Well, we know that 255s is all ones, right? So we have 8 in our CIDR plus another 8 bits. So our mask now includes 8, 16, 24 bits. And then what gives us 192? Well, I can tell you it's going to be 128 plus 64, those first two numbers in the super awesome chart. So that's just 2 bits in this 4th octet. So that's 8, 16, 24, and then 25, 26. So our CIDR will actually be 26. Now again, we can go over this one more time. Let me pull that away, and so we can find it by using our chart. So we knew all ones here, right? So this was 24, and then how many bits do we add from the last octet to complete what we know as our CIDR? And how many bits make up our subnet mask? Well, 128 plus 64 equals 192, and these are just 2 bits here. And with a subnet mask, it's always going to go from left to right when you're adding it. So it's super easy to know any octet you're going to add left to right like that for your mask. So 128 plus 64 equals 192. If it was 128 plus 64 plus 32, it would be 224 in our mask at the last octet. If it was the first 4 bits turned on, it would be 240, right? And then 248, and then 252, and then 254, and then 255. Okay, so currently we have 192 in our 4th octet, and we know that it's a /26 because these 2 bits here are turned on as well in our mask. Now, let's look at another IP address. Actually, it's the same IP address, 192.168.45.55. So we can look at the same IP address, and depending on what our mask is, we're completely changing things, right? Now, our mask was the same in the last 2, so our network ID stayed the same, but now we're changing it up because we have 192 there. And we can go ahead and draw a box around our first 3 octets because we know those will not change. How do we know those will not change? Well, because we have all 255s in the first 3 octets, meaning that the first 3 octets of our IP address will be part of our network ID. So our network ID will start with 192.168.45 something. All right, so let's figure out what that dot something is. Let's look at the 55 in binary. So what is 55 in binary? That's what we get there for our 4th octet. And now we can compare this with our subnet mask, which remember just has these first 2 binary bits reaching into the 4th octet. So the 4th octet mask bits are 1, 1 here. So we can know that everything after that is a host bit and everything before that is a subnetting bit. Now, what is 0 plus 0? What is, if we don't have 128 or 64 turned on in our IP address, well, that adds up to what, guys? That adds up to 0. So our network ID is actually 192.168.45.0/26. Now, you'll also figure out whenever we do subnetting that this is the main work you need to do. So this is the main stuff we need to figure out. And once we write this down on a piece of paper, subnetting becomes so easy. You don't need any formulas. It's just so easy. So we'll get to all that later. But this is really the part you'll need to really become familiar with. Converting decimal to binary, vice versa, understanding how a mask affects a network ID. Once you got that down, subnetting really is so easy. People always say subnetting is hard, but it's not. This is what you really need to understand right here. All right. So again, our network ID is 192.168.45.0. Now our mask does bleed into the 4th octet, but since the IP address we were given didn't have anything in these first 2 binary digits, well, we know that this IP address is part of the 45.0 network. And so here's our mask, guys. And by looking actually at this fourth octet, we can say we could just actually draw a line here. So we can draw a line between our host bits and our subnetting bits. Now this is useful whenever our mask goes in the middle of one of our octets. So as long as it's not, well, if it's just 255.255.255.0 or 255.255.0, something like that, if it's just 255s and zeros, then you don't ever have to do this. But as long as it's anything else, anything other than that, it's useful to have this line we can draw here, and we can separate our host bits from our subnetting bits. So now we know whenever we look at our octet, we can see very clearly where our subnet bits end and what's included in our subnet bits. So again, this is 0 and 0, which means 0 in this fourth octet for the subnet ID. So our subnet ID is, or network ID is 192.168.45.0. If there was something here, if there was a 1 here, our subnet ID would actually be 192.168.45.64. Or if there was a 1 and a 0, it would be 192.168.45.128. Actually, it would be our network ID. But in this case, there's nothing there, so it's just a 0. All right, guys, we can also take the same line and we can move it down to our super awesome, cool, fantabulous magic chart, and that will also give us some great information. For example, we've moved it here past the second bit because we know that there's only two bits in the fourth octet here that we're using in our subnet mask. Now what this tells us is if we add up all these numbers together, that will give us our broadcast for the network, which in this case is .63, right? And that's always one less than the number to the left of it. So 63 is one less than 64. So the broadcast for this network here is actually 192.168.45.63. That will be the broadcast address. If something is sent to that address, it will go out to everybody on this network. It also tells us how many hosts IP address we can actually have, or how many usable IP address rather. So if we add these all up to 63, we subtract 1 for the broadcast, then we know that we have a total of 62 available addresses in this network. 62 hosts, right? Well, 62 IP addresses. Usually we're going to have to assign 1 to our router, right? At least 1 to our router. So it gives us 1 for our router and then 61 for assigning to everybody else. But it's 62 usable IP addresses that we get from this network. All right, that's diving a little bit deep. We won't actually be doing any of that we just did with the line and stuff in this exercise, but that gives you a little bit of idea of what we're going to be doing when we do subnetting and how we can make it so easy. So you don't have to worry about that. I just wanted to kind of give you an inkling of some types of things you can think of and start working on if you want to. But in our practice exercises, it's going to be very straightforward, so don't worry. It's going to be primarily focusing on figuring out binary to decimal conversions and then taking a subnet mask and figuring out what the network ID is. So let's look at another one, guys. All right, I've given you some hard ones so far. Let's do an easy one. All right, here we have a mask 255.255.255.0. And then we can say that we know what the CIDR is because it's 8 plus 8 plus 8. So 8 plus 8 is 16 plus 8 is 24. So that goes ahead and tells us, we don't have to look at our chart, that it's a /24 mask. This is the most common one you're going to see out there, guys. It's the most common one. It allows for 254 usable IP addresses. So that's a lot, right? This is the most common one you're going to see. And it's easy to write, easy to notate. So what's the example? Well, we have this IP address here, 202.10.133.11. What in the heck is the network ID for this IP address? What network does this IP belong to? Well, we can obviously go ahead and draw a box around the first 3 octets, 202.10.133, right? Because we have all 255s in our mask. So we know our network ID is going to start with at least 202.10.133. And then, well, we could break out that last octet, right? Well, we could, but guys, we don't need to do that at all. We actually don't need to do that because our last octet in our mask is a 0, so we don't even need to look at it. We know that our network ID is exactly what we see in the first 3 octets, and that's it. So our network ID, guys, is 202.10.133.0 with the /24 on the CIDR notation. And let's write the mask up there too. So that's an easy one, guys. 255.255.255.0. Other easy ones are 255.00 or 255.255.00. Those are also easy. And also 255.255.255.255. That's a 32-bit mask, meaning it's exactly the IP address. You do see that out in the field.
Jacob Hess here. Thank you guys for viewing the video. I hope you really enjoyed it. And I'd also like to remind you that if you're truly serious about your career in information technology, be sure to check out our Career Blueprint and Engineer Training Program at www.zerotoengineer.com.